how is that going to play out for that mission? Thanks.
So I'll take the first part, and then we'll kind of hand it over to Howard if he has more detail. I will tell you that our teams are actively working right now to a big challenge in and of itself. Then the actual rendezvous operations and the proximity operations are what we're trying to do with Artemis II, but we'll need to do that carefully, and then the docking maneuver. So I'll hand it over to Howard if you want to say more detail about what you anticipate those docking procedures to look like.
Yeah.
Honestly, with Artemis III, first off will be to coordinate the launches and rendezvous. That's going to be a big challenge in and of itself. Then the actual rendezvous operations and the proximity operations, I imagine, will be fairly similar to what we're trying to do with Artemis II, but we'll need to do that carefully, and then the docking maneuver. So I'll hand it over to Howard if you want to say more detail about what you anticipate those docking procedures to look like.
Yeah, I could probably take up the rest of the time talking about my favorite topic of rendezvous, prox ops, and docking. But I'll say very shortly, Orion, we've always been designed and we developed for autonomous capability all the way to docking. So the crew does not need to take over in a manual way. But in the heritage of the shuttle program, where the crew members would take the stick and fly what we call being on the docking axis, so they're right aligned with where the docking mechanism and where the hatches are, and depends on the distance. I can't remember the shuttle time, but for us, it will be something we'll talk with the flight operations team and the crew, whether they would take the stick and finish the final approach and docking, the physical docking, or not. So that's important discussion, but more importantly, just like anything else, you know, we want to make sure we understand our manual capabilities. And so the Artemis II demonstration gives the crew an opportunity to really, I would say, test drive the car. They get a chance to really get a sense of the feedback through the system of how the spacecraft performs. And that's going to be really important. And whether they need to or not for Artemis III, that's, we can decide that later. But to characterize that, to understand that capability and what the spaceship can do and perform and the response that it would provide is really important. And I think demonstrating that Artemis II will definitely give us a great understanding and buy down risk as we move forward to Artemis III and beyond.
The next question is from Will Robinson-Smith with Spaceflight Now.
Thank you for taking the time to speak with us today. Question for Howard Hugh, if I may. We heard from Christina earlier today during the crew briefing about the limitations of the suits as it relates to abort scenarios. But can you go into some detail and talk about, once you get beyond the TLI burn, specifically what are the abort options for Orion if you need to make a maneuver that doesn't get you all the way out to the moon but is more of a U-turn back before then? And then just briefly, what is the abort region weather looking like right now for a launch on the first? Thanks.
Okay, I'll ask. I guess I'll answer the first question. I don't know about the abort weather, so maybe I'll turn to Sean to help me with that. We have very capable abort coverage. You might hear a lot about the ascent piece, but I think you're talking about post-TLI or translunar injection burn that we would do. What we call those is, I would say, less aborts, but early return. And what you would do as we move out post-TLI, we have a capability to return back to Earth at along any point of the trajectory. And it's different types of burns. Certainly early in the mission, I think the first 36 hours or so, we'll probably do what I call turn and burn, which is you would not go to the moon. If there was an emergency, a significant emergency, which we would have to bring the crew home immediately, we would do that burn, execute that burn We've already done all the calculations. We know what we need to do, and so the crew come home safely. After that, it's probably safer at times from a time perspective to fly around the moon and come back and take that free return trajectory. You're not getting any more time savings, and you don't have to do another big burn. You're already on that path forward to hitting our entry corridor. And so I think that's where we will make a decision as a mission management team to determine how best to move forward. But we do have a continuous early return capability that we've already run hundreds of thousands of trajectories against and ensured that we are able to get the crew home safely.
Yep. As far as launch abort weather is concerned, it's currently forecast as go on Thursday. We have 3 types of aborts that we could do right after launch. One is called a LAS abort, a launch abort system abort, where the spacecraft would land, fairly close to the launch site, and then a untargeted Atlantic abort, which would land somewhere across the Atlantic near Africa, and then abort once around possibility if we went into a single orbit and then come back down near our nominal landing site in San Diego. Our recovery forces are gathering as we speak out in San Diego. All the equipment that we're going to use for recovery is being loaded on the ship as we speak, and we're ready to go as far as our abort scenarios are concerned.
Our next question is from Christopher Mick with the Hudson Star Observer.
Thank you all for doing this today. I guess my question kind of follows up onto what was just mentioned. I know you don't have everything available at this time, but if the launch were to happen at the beginning of the 2-hour launch window on April 1st, can you talk about what approximately the splashdown time would be off San Diego?
Ooh, I don't have that.
We can follow up with you.
We'll follow up.
Absolutely.
Once we do that TLI burn, it's set, but we'll find it for you.
Okay, let's go back to several more here in the room. We'll come on this side here in the front row.
Hi, Josh Dinner, space.com. Are there any even minor technical issues or risk assessments that are still open that may pose a potential of pushing the launch into any, by a few days into this window?
I mean, I'm going to jump in. You're looking at Sean shake his head no there. There's little things that we find as we go that we're working right there, but none of them are threatening the first right now.
Yep, I would agree. I mean, we had a minor issue on our flare stack where one of our pilot lights don't work. We have 3 of them. One of them doesn't work. We're going to fix it tomorrow. But that's the kind of stuff we're talking about right now. And I'll take that any day.
Yeah. And the vehicle's quiet. We're not working anything?
Yeah, we don't have any issues with working, like I said.
Okay, we'll come to Philip Sloss.
Hi, Philip Sloss. I think this is for Chris. Just following up on questions from Irene and earlier. It sounds like there's a lot of SLS hardware for Artemis III that's going to be coming to the Cape here this month, or April. I had one follow-up on that, which was when the 4/5 gets here, is the engine section going to be ready to do that final mate with it?
There is some work still to be done when it gets here. It's not like it rolls in and lifts up. So there's a little bit of work that has to be done, but it's all part of the plan. And but it's ready, and based on our assessment last week, right? We looked at where everything was in the supply chain and the work that's being completed. When Sean's going to need it, we're going to have it ready for him when it's time to hang it on the boosters. We'll be ready to go.
Okay, we'll stick here with the room.
Thank you. Manuel Masanti with Exploración Espacial. Did anyone, or did the CubeSats on board the mission need anyone of any kind of servicing, or they're fine and ready to go?
Yeah, I can tell you we are carrying 4 CubeSats, 4 payloads, secondary payloads from our international partners, 4 different international partners. We have one from Argentina, Germany, South Korea, and Saudi Arabia. Thank you. And I think only one of them required a top off on their battery. The others were fine. They didn't need any work. The 4th one, the battery was topped off, and it's fine. So they're all in very good shape, ready for launch.
Okay, we'll go here to Ken.
Hi, Ken Kramer. Thank you. Thanks for this update, and good luck with everything. Howard, let me ask you, can you describe the POXOP proxops in a lot greater detail than what we've heard. And I want to know how close it will be to, like, when you would do the human landing system docking on Artemis III. I guess it's going to be informed there, but can you go into how much? And what are we going to see in real time? You're going to have video of this proxop demonstration? Thanks.
Yeah, I don't know about the video part, but I'll just give you some quick highlights. You know, we separate from the upper stage, and then we'll go out probably about 100 meters. So we'll flip over, and then we'll start doing the approach. And the approach will be all the way to about 10 meters, so about 30-some feet. And so the crew will be manually piloting along the way. There's specific things, tasks they're going to be doing. And it's going to be very exciting, I think, to just not only because of new spacecraft, but something that we will play forward in terms of what their ability, like I said earlier. And so that demonstration, then there's a second part, which we back away again and do a hold. And then actually I would say the ICPS slews over, and then we do another approach. There's other reflectors on the side of the ICPS that we're using to dock or to reflect from, and to get understanding how that would work in terms of visualization from our docking camera. And so those things will be very important for us to understand the close-in approach. Now, rendezvous proximate docking is thousands of miles, right, starting at very far away. So you're getting very close in terms of what the final sets of our ability to do proxops and demonstration for final mission. But there's a lot of work prior to that. Obviously, we can't do that. Now, we will do some long-range bearing. We have a bearing camera, as we depart from ICPS and capture all that data as we go forward. So the equipment that we need to understand the environment that we're going to be under and what we would get is really important to capture for this mission. But certainly there's still a good amount of work remaining to do to enable for us to do the entire rendezvous proxops and docking scenario.
And Ken, to your question about what you can expect to see, we do expect the public will be able to see the same view from the docking camera that the crew is seeing. So we'll be able to show you that if all's going well.
Oh, that's going to be exciting.
Okay, our next question, we're going to go back to the phone. This is from Claire Cameron with Scientific American.
Hi there. Thanks so much for doing this. I did want to ask again about the potential for space weather and how you are sort of planning for that and whether that could have some impact on launch date. Thanks.
I believe I saw a note this morning that says right now we're not watching anything. In the weather report we got today, it said the space weather risk was low, but we can look and see if we can get you additional detail. But that's right now we're not keeping an eye on anything.
Okay, our next question is from David Denault with About Space Today News.
My question is for Howard. This morning, there was two comments made about how Orion might be performing. The first one, I believe it was Commander Reed, who said something about having the addition of the life support system might have an effect on how the spacecraft might operate. And the second one I found interesting was about exercising inside the spacecraft and how that might affect the Orion spacecraft's operations. Could you comment on those two, please?
Yeah, you bet. The first one, the way we get rid of carbon dioxide is vent it out of the spaceship. So we have a component called the CO2 humidity control box, and that box absorbs the CO2 that comes out of human beings, and then we dump it overboard, and that's venting. And you can imagine, if you're anywhere a physics student, you can imagine that when you impart a force on the vehicle, whether it's venting or anything else, you got to counteract that force. And so that's what we talk about when we talk about the ecosystem imparting some things on the spaceship. So we have to correct that. We have a very robust attitude control system, closed loop. And so it'll adjust to any of those situations. And we could swing this CHC, or the CO2 humidity control system, 15 minutes, 30 minutes, however we want, based on what we need, how much CO2 we need to remove. And so this is going to be an important understanding of how the spacecraft controls our attitude of the vehicle and make sure that it responds to this venting environment. So that's one piece. And then the second thing is very related as well. We have a flywheel. That's our exercise device. Think about, it's not exactly a rower. If you go to the gym, it's more than that. But you can see as in a rowing kind of motion, which is what they're going to be doing in space, you can see that there's dynamics involved in terms of the forces that are being applied from that motion. And those forces have to be counteracted from a spaceship perspective as well. So our jets, our reaction control jets, will be augmenting or dissipating any of those things. So that's going to be really interesting test as well. We're going to try to, I think, cycle through each crew member 30 minutes of exercise a day is, I think, our plan still. And then we'll have a lot of understanding of the dynamics. And it's really important that, obviously, as we go into deep space, that the human body gets to exercise. And we're learning a lot on this mission beyond what we have in Space Station. Space Station has a lot of great exercise equipment. You can't put all the treadmills and things like that on our spaceship. And so this flywheel is a really great exercise tool that we're learning from and utilizing as we go forward.
All right, we'll take one more question from the phone, and then we'll come back into the room here. Our next question is from TJ Mascaro with the Epic Times.
Good afternoon. Thank you all so much. Question for Lori and Howard. When we were talking to the astronauts, they mentioned an eclipse event if they launched on April 1st and 2nd. Can you all talk a little bit more about that, what you're expecting and preparing for?
Sure. So I'll speak to it from kind of the exciting science part of it, and then Howard can speak to it from the Orion performance side of it. Yeah, I think it's going to be very interesting in this flight if we are able to launch on the 1st. The crew are going to get to have some pretty interesting eclipse opportunity to be able to look back at the disk of the moon with the sun being in eclipse. And I think from a science perspective, they'll be able to see the sun's corona. And I think it'll be really fascinating and a great kind of observation opportunity for the crew there. It's kind of I think going to be a unique thing on this one. Go ahead, Howard. You want to speak to the?
Yeah, I think I get questioned a lot. When are we launching? Why is this day in? This day is out. There's a lot of several factors, obviously, but power is one of the analysis that we do to screen for eclipses. We know where the eclipses are happening, and we want to make sure we're power positive is what we use the word for. And so when we screen across multiple trajectories, multiple days, every minute of the launch period, by the way, to ensure that we have significant power positive margins when we enter into a eclipse, and then making sure that there's not other segmented eclipses that could happen, so we have time to recharge our batteries. And so when we do that, we run hundreds of thousands of trajectories per each launch period. And so I think many of you asked, when can we launch? A lot of that work across multiple launch periods are being done by a really great team. And we look at all the power and any abort cases as well. Also, when we have abort trajectories, we will also have eclipses. So for both nominal and abort, for the April 1st to the 6th, we've got power positive margin. And so that's why we can say that we can fly these missions with confidence.
All right, we'll come back into the room. Let's go over here to Marcia, and then we'll come to Josh.
Marcia Dunn, AP again. Lori, I've heard you say you're figuring on 4 real true attempts 6 days. How do you figure that? And a countdown question, if it's just the weather and the rocket's sitting on the pad for 2 hours and doesn't go, if it's just weather, can you turn that around in 24 hours and try the next day?
So I'm going to talk to just a little bit, and then I'm going to hand it to Sean because he can probably give you more detail. So we have 6 days that each of those 6 days, the 1st through the 6th, are viable launch days. But we do need to, if we do a scrub, there's at least 24 hours to turn around. And in some cases, we need to replenish some of the the gases and things that we need to fuel the spacecraft and run the spacecraft. So those sometimes we'll need to do a 48-hour scrub. So if you take the 6 days that we have available, if some of those are 24 opportunities and some of them are 48-hour scrubs, we think we can get up to 4 launch attempts within that 6-day period. Sean can speak more to the resources that are required and what drive the 24 versus 48.
Yeah, as part of getting ready for Artemis II, we actually installed a new 1.4 million gallon hydrogen dewar. And so that enables us the 4 launch attempts that Lori referred to. Whether it's a 24-hour scrub or a 48-hour scrub really depends on the reason. It depends on what the hardware problem was, or when we scrub in the launch countdown. So if we're real late, that means we're using more hydrogen. We're bleeding off more hydrogen. If we scrub early, we're not bleeding off as much. But we're prepared for a 24-hour scrub turnaround for just about any case.
So if it's purely weather.
Yeah, if it's purely weather, we can hit a 24-hour.
Okay, we'll come here. Let's wait for Mike to come around. Yep.
Hi, Josh, dinnerspace.com again. Howard, this one's for you. You mentioned Orion's attitude control system, and I know there's a demonstration of the 2 different attitude control modes during the mission. Can you talk about the differences between the 6-degree and 3-degree of freedom configurations, and which scenarios, both of them, are sort of advantageous over the other to be used?
Yeah, wow, that's a very good question. I wasn't expecting that. Okay, so going back to guidance, navigation, control. So 6-degree of freedom allows you to obviously do X, Y, and Z and translate as well. So for us, we're always in the 6-degree of freedom configuration. That gives us the fine control. If we needed to, we'd go to a 3-DOF to clean, or 3 degrees of freedom to clean it up if necessary based on the RCS configuration. But in general, and then we're going to do a test of both, right? Our ability to control the spacecraft is really important, and our ability to have a closed-loop control system that allows us to do both, and a jet selection logic along with that. So we have multiple jets that we can use to fire together in combination is really important as well. So all those things are part of our, I guess that the answer is yes, we're going to do both. Yes, they're very important, but in general, 6-degree of freedom is the control mode that we would generally want to be in.
Okay, we'll go to one on the phone. We have Micah Maidenberg with the Wall Street Journal.
Hey, thanks, Rachel. Maybe for Lori, could you remind me just about the role of the prime contractors at this point, specific to SLS and Orion? Like, are folks from the companies actively working with NASA teams right into launch, or is it more they're on standby if something comes up? Some color there would be great. Thanks so much.
Yeah, thank you for the question, Micah. In fact, I'm really excited to answer this one. We are still working very, very closely with all of our prime contractors. In fact, the issue that we had that required us to roll back to the VAB, the helium quick disconnect connection there, was a great example that showed our NASA teams and our contractor teams from Boeing and ULA and from our ground system contractor teams and our NASA teams all working together as one team. It was fantastic, and it's great to see we're just trying to solve the problems and get the work done. So we are working really closely with our contractors, all the contractors and the NASA folks, including the folks from Boeing, Lockheed, ULA, Northrop Grumman. We're all in there together, and there's more as well, but we're all in there together. And when we get questions about how are we going to turn around faster and be able to implement the accelerated plan that the administrators rolled out for Artemis 3, 4, 5, and beyond, I think this is the way we're going to work together in the future, much more closely and more integrated and more collaboratively with these integrated teams. So it's been a great demonstration here.
Okay, let's go on this side to Lauren Grush again.
Hi, thanks for taking a second question. I'm just curious, what, if any, flexibility do you have with the biggest maneuvers that you have planned in space? For instance, if a burn doesn't happen exactly at the right time, is there any wiggle room, or are there just some maneuvers that have to go off as planned or else they can't happen? Thank you.
Maybe that's...
You want me to take that one?
Yeah, why don't you take that, Howard?
So all our burns that are on Orion's side, obviously including the translunar injection burn, we have a recovery plan. So 2 things could happen. One, if your main engine cuts out, So we have our auxiliary engines that would go forward. We also could also do a replan of that and continue that burn as well. So that's there. We certainly have covered all the other burns. There's one burn that's we call critical that must be done. It's our return trajectory correction burn 3. RTC 3, it's about 5 hours before we hit entry interface. That really corrects and makes sure we hit that corridor, which is really important, obviously, for making sure we can get the crew home safely through the Earth entry point. And so that's our only burn that is critical. The rest we can replan, I would say, and clean up as necessary if we do not get a full burn off.
Okay, let's go to Bill Harwood next.
For Mr. Quinn, I'm a little confused on the recycle options. I thought if you gassed it up and got late in the window, you couldn't do a 24-hour turnaround. That it's some limit that, if you put fuel on board, that affects when you can go again. I just wanted to clarify that.
That was true for Artemis 1. It's not true for Artemis 2. We've got the 1.4 million gallon sphere that gives us a much more significant hydrogen storage capability at the launch site.
You can go later in the window and still recycle.
Yeah, I believe so. I mean, I'll confirm, but I believe so. Yeah.
Irene next.
I also had another countdown question. Is there a point in the count where if you hold or for weather or technical issue that you no longer have the whole 2 hours? Like if you get into terminal count, is it commit? I mean, are you able to stop and retarget later in the window, or do you lose some options at some point in the countdown?
Yeah, we can recycle about T-minus 5 minutes. If we hold a count before T-minus 5 minutes, we can recycle back and try for another attempt.
Okay, we'll take another one on the phone from Will Robinson-Smith with Spaceflight Now.
Hi, thanks, Rachel, for allowing another one. Question to, I suppose, whoever wants to take it, maybe Sean. If the ICPS isn't able to get Orion into the high Earth orbit, but the Orion module, both crew and service, are working just fine, what would a low Earth orbit version of Artemis II look like? About how long would that last, and what operations could you accomplish in that scenario? Thanks.
Probably a question for Howard again. Howard,
so we also have what we call alternate mission scenarios, by which we allow ourselves to potentially do a circular orbit. We have a couple options to circularize and execute as much of the objectives that we can. If there's something that happens where we could not get the upper stage to get us a nice burn. So there is various options we looked at. We're able to do some of those mission completion things, and it depends on where we get dropped off, what happens. So it depends on the scenario we're in, but we're definitely ready for those types of scenarios as well. And the flight control team knows what to do. We've already done the planning for that. We've already assessed a lot of those trajectories to make sure that we're ready to go and have them in hand if necessary.
Okay, we'll go actually back there to Miles Doran.
Doran, CBS News. Question for Howard. I know the main engine is used for the TLI burn. Which engines are used for the other burns, the OTC burns, the RTC burns? Is it all the auxiliary thrusters, or can you use both? What's the plan?
The ohms burn is too much. We don't expect to make that correction. Our navigation state should be very good unless something happens along the way and we can't. So all of them are planned to be on the what you call auxiliary or aux burns. If they're small enough, we might even do in the reaction control system on the service module as well. So that'll depend on, as we approach each OTC, each RTC, which is outbound trajectory correction, and then return trajectory corrections, we'll determine how best to utilize our thrusters. But yes, in general, it'll be the auxiliary engines.
Okay, let's go to Ken here in the front.
Thank you. Thanks for a second question. Ken Kramer, Space Up Close. Howard, what is the width of the reentry corridor? I don't know if I've heard a number. And I would also like to get an update on the RS-25 engines. You got to build new ones for Artemis 5. We haven't heard a lot about it. So what is the status? Because if you're going to launch Artemis 5 in 2 years, you got to get them built and tested pretty soon. Thanks.
Yeah, when you say width, I'll have to get back with you on what you're asking. You mean the width of the corridor in terms of cross range? Is that correct? The cross range. We got a downrange track of up to 1775.
Well, I think even as they approach, right, there's a corridor before they get there.
Yeah, I'll have to get you that number. Sorry, I don't remember off the top of my head on that one. Okay.
Because astronauts are real concerned about that.
Yeah, I can probably delve into more of it, but we'll get you that number. Okay.
Okay, and on the RS-25, right, for Artemis 5, they are in production, flight set. So we've also completed our acceptance hot firing on 2 of those new engines already. So they are in the production phase, and we're working through it. You'll go back. You can pull some of the burns and the tests from Stennis when we went through those tests of those new engines. So they're in play, and they would do support.
All right, and with that, we'll go ahead and wrap up. I want to thank our participants very much for being here today. We will provide another status update tomorrow on how the countdown is going as it gets underway. That'll be at approximately 5 p.m. Eastern Time tomorrow. As always, you can follow the latest news and mission events and our progress on nasa.gov. Thank you for joining us.